Notes today in your note packet, Roman numeral 2 navigation. We were supposed to have the formative, but we moved it to Tuesday. And then there will be a video to watch. I'll post it this afternoon, and it will be on the page right before this one. It'll be on Roman numeral 1, multiple forces. Okay, so that video we'll watch that video on, or you will watch that video sometime before Tuesday, and then it'll be short. It'll only be maximum 15 minutes, I promise. Okay? If not, I'll apologize in the middle of the video, and then you'll get the apology. Okay, so that'll happen this weekend too. All right. So today we're going to start talking some more navigation type ones, but we're going to be true navigating. Okay. So a couple of things to remember about. Come on now, why didn't that move up? What is going on here? Why won't this? Oh, I see. That's why. It's all one thing. There we go. A couple of things to remember about the navigation. So first off, remember when we are navigating, north is up, and that's 0 degrees. East is to the right, and that's 90 degrees. South is to the bottom, and that's 180 degrees. West is to the left, and that is 270 degrees. You can get a bearing angle either in regular angle form, 223 degrees, okay, bearing of 223 degrees, or you could get it the north-south angle, east-west type form. Okay, so those are your two options in terms of that. Remember, and this is going to be extremely important today, remember that you need to make whatever angle you have into a trig angle to use it. Okay? So whatever angle you have is great. You set the angle, but then the first thing that you do is you switch everything to a trig angle. Okay? That's rule number 1, step number 1. Switch it back to trig. Do it all. Do all your calculations. All of your calculations are done in trig angles. Then at the end, you got to switch back. I know it's a pain, but I get it. Okay? So what we're going to deal with today and Tuesday and probably Wednesday is the example that I used in one of my classes earlier this week, where I said some of you just went on an airplane for spring break. Okay? So if I am flying from the city of Linz to the city of Ashley, okay, right? And I am the pilot, I'm the captain, okay? I set it, I'm pointing right at where I want to go. We're in the air, we take off, we get lined up, okay? I'm going to go. And I would fly straight if there's no wind, okay? And everything would be fine. But if there's wind, okay, let's say there's a hurricane tailwind blowing through and blowing this way, okay? So she's blowing, and then boom, now all of a sudden, on that same angle, now I'm over here. Totally missed my destination. Okay? So we have to factor in that thing if we're on a ship. Okay? If I'm leave Port Linzmeyer and I sail to Port Ashley, the current, same thing. Okay? Currents have an effect on the vessel that you're doing. Current, wind, and all that fun stuff. So to compensate for that, we came up with this simple little equation. A plus W equals G. Okay? Where A is going to be your vessel, your plane, your ship, your hot air balloon, your kite, whatever you want it to be. Okay? W is going to be the wind or the current. What else could affect something? Those things. Gravity. Okay? And G here is going to be your true. What you're actually doing. So from that vector, and from all of these vectors, we can get magnitude, that's speed. We can get direction angle, that would be bearing. Okay? So that's true. So whatever your vessel's doing, plus whatever is being acted on your vessel, is going to equal what you're truthfully doing. Okay? A plus W equals G. Let's do number 1. Okay? Or the first one right there at the bottom of the page. Okay? So a plane, I'm going to read it and make sure it's the same one. A plane has an airspeed of 450 miles per hour bearing 150 degrees. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? Okay? So we start with our equation, if you will, is going to be A plus W equals G. This is A, because it's my airplane, a plane. That's my vessel. My vessel is the plane. Okay? Out of that, we need to make a vector. Okay? So my vector A is going to be, now this is where we think back to our vectors. Okay? In component form, our vector was magnitude times direction angle, or excuse me, forgot the trig word in there. Magnitude times the cosine of the direction angle, comma, magnitude times the sine of the direction angle. Okay? So if we have vector A, it's traveling, its magnitude is 450 times the cosine of its direction angle. Now, we've got to convert a bearing of 150 degrees into a trig angle. So a bearing of 150 degrees would be in which quadrant? Let's see, which quadrant is a bearing of 150 degrees in? The fourth one, yep, because 0's up top, 90's here, 180 is here, so a bearing of 150 degrees is down here. What is that trig angle? 300? Do we all agree with 300? Yep, 300. Now, the nice thing is that because we're going to be using these a lot, we don't want to round until we have to round. Okay? So what is the cosine at 300 degrees? One half. Okay? 1/2 times 450. 225. So this horizontal component of vector A is 225. What is the sine at 300 degrees? You did it right, but just wait. Don't write it that way. What's the sine at 300 degrees? Square root of 3 over 2. So what is the square root of 3 over 2 times 450? Exactly. $225 times the square root of 3. Now, I stopped Lexi up here only because I'm literally almost standing in her lap from writing down what had you written down? Negative 389.7114 blah 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 blah. Okay? Because we're in quadrant 4, this should be negative, right? Because really the sign at 300 is negative root 3 over 2. Okay? Now, the difference between writing it as negative 225 square roots of 3 as opposed to writing it as negative 389.714317 is what? What's this one compared to that? This one's an E word. This one's an E word. This one's an R word. Exact versus rounded. Okay? All right? Keep it exact as long as you can. Okay? So that's our vector A. Now, we need to find vector W. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. So my wind is going to be 50 times the cosine of, okay, now we got to figure out that angle. Wind is blowing with a bearing of 60 degrees. So is it blowing to my 60 degree angle, or is it blowing away from my 60 degree angle? Wind is blowing with a bearing. With or not with? With, right? So it's going to 60 degrees. So that's in quadrant number 1. What is my trig angle? 30. Cosine at 30 degrees. It is pi over 3. No, it's not pi over 3. Cosine at 30 degrees. Square root 3 over 2, because it's at pi over 6. Yeah, okay? So, square root 3 over 2 times 50. Square root 3 over 2 times 50. You should be able to do this one without even thinking. Like, I shouldn't have to wait. Thank you. Okay. 25 square root of 3. 50 times the sine of 30 degrees. 25. Okay. Do you see the pattern? Because everything up there on the unit circle is what? Every coordinate on the unit circle is what? What's the same with all of these? Everything's over 2, right? So all you got to do is divide by 2. And then if you got to put a radical, you got to put a radical. Okay? But you just have to divide by 2. Okay? So then this is going to be plus. Okay. With me? How do I add vectors in component form? Go back to last week. Adding vectors in component form. Actually, this is important. Right? Adding vectors in component form. You just turned in a worksheet where you added a bunch of vectors in component form. Add the horizontal parts together and add the vertical parts together? Yeah. So this is going to be the vector 225 plus 25 square roots of 3, comma, negative 225 square roots of 3 plus 25. We've kept it exact as long as we possibly could. Now it's time to get it out of being exact. So calculate those values for me, please. Do you agree? Okay. So that is the vector of our true ground speed and direction. How do I find the bearing? How do I find the speed? How do I find the bearing and how do I find the speed? We got you.
Probably like plot the x component and y component on the graph.
Okay. And then what would you do for direction? law cosine. What do we have here in black? Right here. This is vector G, right? It's a vector, right? Is there an easier way? Okay. Is there an even easier way? Maybe if we turn back one page. Maybe in an in general box. Because it's a vector. What do I need to find with that vector to get the speed? What do I need to find with that vector to get its speed? It's in the in general box. What do you think it is, Jacob? What is that? Nope. It's some special part of a vector. Keep looking back. Look in your notes. I'm not going to give this one to you because you should know this. This should have been, 5 minutes ago, we should have been done with this problem. I'm not giving it to you. I'm going to make you struggle through it. What part of the vector is speed? I have already said it today. Magnitude. We just need to find the magnitude of this vector. Find it. Tessa, is yours exact as mine? You were given it to look like, why is mine different than the one that's on my calculator? Got that one? How do I find this vector, this plane's direction angle? Or this plane's bearing, I should say. Okay, so it's going to be the direction angle of, oops, I put Q. Backwards G. Inverse tangent of what? Which part? Which part was on top? The horizontal or the vertical? Vertical. What do I do with that negative sign? Get rid of it. So it should just be 364.711 over 268.301. Okay. Find me the reference, or that's going to be the reference angle. because we are not in quadrant number 1. Agree with me on that? Okay? So now we've got to figure out where this vector is. It's not like when we were doing trig and we had a reference angle of this, and then we either added it to 180, we subtracted it from 180, or we subtracted it from 360. Okay? What quadrant is this vector G in? It's in the 4th quadrant because it's positive and it's negative. So it's in here. Which means that this 53.6598 angle is right there. So what is the bearing angle? How'd you get it? Added that 90 because that comes off of the top up here, and that bearing angle comes all the way there, so that is 143.66 degrees. So the plane's true speed is 452.77 miles per hour, and the true bearing is 143.66 degrees. Now, I will tell you 2 things. First thing is, 1, that was painful for me. Okay? You need to know your vocabulary much better. You need to know what this stuff is, because unfortunately this stuff isn't going away. We're going to use this for the next couple of months. Okay? Right? So get to know that vocabulary. That's your first part of your homework for this weekend. Second part of your homework for this weekend is you got to watch some more videos. So you're going to have to watch the video on multiple forces for this weekend. Okay? Those 2 need to get done. We'll pick up on this again on Tuesday, okay? And hopefully it will go a lot easier, because that was a little bit painful. Now, the other thing that I will tell you is, going back to the start of this problem gave us bearing angles as angles. Okay? So that's how we would want the answer. If this problem had given us the plane has an airspeed of 450 miles and a bearing of south 30 degrees east, then that's how we want the bearing in the answer. Understand what I'm saying with that? So if it's given to you as an angle, give me an angle. If it's given to you in compass rose, give me compass rose. If it's in the north-south angle, east-west, give it to us in that way. Okay?